Hey guys, today we're going to be doing a video on problem number 69 from chapter 10, and this is a pretty difficult problem. If not, it's probably the most difficult one that we have from the ones assigned. And it basically reads that you have this pendulum with string length L and mass M, and there's a peg right here at height L over 3, and you want to find out the minimum angle to extend it at so that it can fall, reach a critical velocity right here, so then it stays taut throughout this it follows this path where it goes down and stays taut in a semicircle, right? So you don't want it to slack. So the first part of the problem is to find this critical velocity. So there is some critical velocity right there, right? Velocity tangential critical that you need, and the minimum one would obviously be just with the force of gravity. So what you're going to do is you're going to write your F net in the R direction, right? Because we're looking at radial stuff. Semicircles is going to be due to mg. So you're going to have mass times acceleration in the radial direction equals mg, right? So immediately the m's cancel out, and then you have so acceleration in the radial is velocity tangential squared divided by radius equals g. So you have your velocity tangential critical is going to equal radical rg, and for the sake of this problem specifically, you know your r is L over 3, so the critical velocity is going to equal radical Lg over 3. Perfect. Now the second part of this problem is to actually find the height at which to release it. So the easiest way to do this is with conservation of energy principles. So if I have my ug initial plus kinetic initial equals ug final plus kinetic final, so I'm going to have mg y initial plus 1/2 mv initial squared equals mg y final plus 1/2 mv final squared. Now looking at this is going to cancel out because my velocity initial is 0. mg y initial, I know okay, so I'm just going to leave it like that for a second. My mg y final, I know my final height has to be the height of the peg. I mean, that only makes sense. So it's going to be mg times L over 3 plus actually I'm going to remove all the m's, right, because you see that they're equivalent throughout. So my 1/2 v final squared, so 1/2, and right here is going to be my v final is going to be my v critical, so it's going to be just Lg over 3 because the squares cancel out, so it's going to be 1/2 times Lg over 3, and that should equal my gy initial. Now remember, we're trying to find y initial, so it makes sense that we don't have it just straight away. So just a bit more getting rid of some more things, and you can see that I have gl over 3 plus gl over 6 is equal to gy initial. Once again, the g's cancel, right? So y initial equals L over 3 plus L over 6. Now that should just be, so if to get this even, it should be 2L over 6 plus L over 6, and that should give me 3 over 6L, which equals L over 2. Awesome. So now we have our y initial. So let me scroll down. Y initial equals L over 2, right? but you have to remember that the L over 2 is in perspective to the peg, so it's going to be L over 2 up the peg, so half. So we basically changed our L to that, right? So L over 2 is there, but remember we want it for the longer L, so we redefined L. So I should have probably made it a some cursive L of this sort, so I could go changing all those, right? But I have L over 2, and basically the way to get the height, so now to get a height, if I draw a better picture, which is more like of scale, you would see that the pendulum would be somewhere up here. Here's the peg, here's L over 2, and the height that you want is right there, right? So the way to get that height is to simply do, it should be L minus L over 2 minus L over 3, right? Because I'm subtracting the L over 2 and the L over 3 from the whole height. And that should give me, you guys can just do a bit of math, arithmetic right there, and it's L over 6. So the height I want to start at is L over 6. And now if I have my theta here, I know that my cosine of theta is going to be adjacent, which we just found out is L over 6, over the hypotenuse, which is L. So I can times 1 over L. Those cancel, right? So I have my cosine of theta equals 1 over 6, which is equal to cosine inverse of 1 over 6, and you get 80.4 degrees. And I know that's a very complicated problem, but I think if you guys just sit around, maybe experiment with it, especially this L over 2, I know that's where it gets really, really trippy kind of thing, but it makes a lot more sense if you guys try to work it out by yourselves one more time. I know, especially when took me a couple of tries, but eventually when you do it yourself, you realize what is actually going on. Thanks for watching the video. Hopefully it helped, and good luck on the test.